Good morning, friends. Welcome back to another exciting calculus lesson with Mr. M. Today we are looking at differentiating composite functions. Without wasting time, let's get on with it. Suppose that you have a function, you are given a function as an example. Y is equals to 2x cubed plus 3x squared plus 1. All this is raised to the power 2, and we want to differentiate this function. This is a composite function because it's made up of two functions. There is a function inside the brackets, which we shall call u, and there is the whole overall function, which we shall call a function of x, okay, f of x, and this is f of u inside, or a function of u. So to differentiate this type of function, we say dy with respect to x, the derivative of y with respect to x will be equal to dy with respect to u multiplied by du with respect to x. And this is sometimes referred to as the chain rule, because this rule is off the chain. You know what I'm saying? No, I'm just kidding. This is referred to as the chain rule. dy dx in a composite function is equal to dy du multiplied by du dx. Let's take some examples. Oh, beg your pardon, we do have an example. Differentiate y is equals to, in brackets, 2x cubed plus 3x squared plus 1. Let's do it. So what I'm going to do is first dy dx is equals to, now I have to differentiate the function that is contained inside, okay, and then multiply that by the function that is outside. So the chain rule, in very crude form, you can say states that it's the derivative of the outside evaluated on the inside multiplied by the derivative of the inside. Derivative of the outside evaluated at the inside multiplied by the derivative of the inside. Derivative of this whole thing evaluated at the inside. Derivative of the outside evaluated at the inside multiplied by the derivative of the inside. The derivative of the outside, now if you take this whole thing as one variable u, and you have a square there, so if you are differentiating u, dy du will actually be equals to 2u multiplied by the derivative of the inside, du with respect to x. Okay, so let's put this in perspective. Dy dx is equals to derivative of the outside. Imagine this whole thing is one thing. Derivative of the outside will be 2, whatever this is inside, evaluated at the inside, 2x cubed plus 3x squared plus 1. Derivative of the outside evaluated at the inside to the power 2 minus 1, which is 1 there, times the derivative of the inside itself, times the derivative of the inside, which is 6x squared plus 6x plus 0. Okay, and hence your dy dx will be equals to the product we get when we multiply all that function derivative there. Okay, derivative of the outside evaluated at the inside multiplied by the derivative of the inside. Derivative of the outside evaluated at the inside times the derivative of the inside. Derivative of the outside evaluated at the inside times derivative of the inside. And that is called the chain rule. Thank you, friends. Let's move on to another tangible example. Please turn with me to page 171, exercise 5H. Page 171, exercise number 5H. Question 1. Use the chain rule to differentiate the following functions. Question 1, Roman figure 1. Use the chain rule to differentiate the following functions. The first one is y is equals to x plus 2 squared. So dy dx will be equals to derivative of the outside evaluated at the inside. So the outside is derivative of the outside will be multiplied by the power 2 evaluated at the inside. X plus 2, you don't do anything to that at this stage, to the inside function, to the power 2 minus 1, which is 1, multiplied by the derivative of the inside. Derivative of x plus 2 is simply 1. Therefore, in this case, dy dx is equals to, if you multiply out and simplify, that's going to be 2x plus 4. Number 1 done. Roman figure 2. Y is equals to 2x squared plus 3 all raised to the power 4. Y is equals to 2x squared plus 3 all raised to the power 4. Dy dx will be equals to derivative of the outside evaluated at the inside, so the coefficient gets multiplied by the power 4, so you get 4 in brackets evaluated at the inside plus 2x squared plus 3 all raised to the power 3 times the derivative of the inside. The derivative of 2x squared becomes 4x, and the derivative of 3 is just 0. And this becomes your derivative of this composite function. Okay, guys, please keep practicing. Thank you very much for watching. Keep safe, keep well, and hopefully see you soon. Bye.